Imagine for a second that you are standing in the middle of a vast, infinite museum. Every room is filled with the most incredible artifacts. In one room, you have the birth of stars, glowing like cosmic nurseries. In another, you have the terrifying majesty of black holes, warping the very fabric of reality. You walk through corridors of dark matter and hallways of shimmering pulsars. But then, you reach a door at the very end of the hall. It is a plain, heavy door with no handle, and every time you ask the museum curators about what is behind it, they look away. They change the subject. They tell you that the room doesn't matter, or that it is impossible to see, so why even bother trying? This isn't just a metaphor. This is the current state of modern astrophysics. There is a specific part of our universe, a region so massive and so significant that it encompasses nearly half of the sky from our perspective. Yet for decades, the scientific community has largely treated it like a galactic blind spot. We call it the zone of avoidance. Now, the name itself sounds like something out of a low-budget science fiction movie, but the reality is much more mysterious. It is a place where our maps go blank, where our most powerful telescopes struggle to peer through, and where some of the most massive structures in the cosmos are hiding in plain sight. Today, we are going to peel back the curtain on why this region has been so ignored, the terrifying things we have started to find there, and why some of the most brilliant minds on the planet are quietly terrified of what that empty space represents. Stick around, because by the end of this journey, your view of the night sky will never be the same again. To understand why scientists avoid this region, we first have to talk about where we are. We live in the suburbs of a massive swirling disk called the Milky Way. When you look up at a truly dark night sky, you see that beautiful milky white band stretching across the stars. That is the edge of our own galaxy. It is full of billions of stars, massive clouds of gas, and gargantuan amounts of interstellar dust. And that is exactly the problem. Imagine trying to look at a distant mountain range while standing in the middle of a dense, smoky forest fire. The smoke is so thick that you can barely see your own hand in front of your face, let alone the peaks miles away. For astronomers, the Milky Way is that smoke. The zone of avoidance is the area of the sky that is obstructed by the primary plane of our own galaxy. Because we are sitting inside the disk, when we try to look out into the deeper universe through the thickest part of the Milky Way, all we see is our own internal clutter. Dust particles, though microscopic, are incredibly effective at scattering visible light. This is why, for the longest time, the map of the universe had a giant, jagged hole in the middle of it. We could see galaxies millions of light years away in every other direction, but in that specific band, it was just nothingness. For a long time, the refusal to study this area wasn't necessarily out of fear, but out of pure frustration. If you are a scientist with a limited budget and limited time on a telescope, you want results. You want to find new galaxies, measure the expansion of the universe, and hunt for exoplanets. Trying to look through the zone of avoidance was seen as a waste of time. It was the equivalent of trying to take a picture of a bird through a brick wall. So the scientific community developed a habit. They just looked elsewhere. They pointed the Hubble Space Telescope and other massive observatories at the clear parts of the sky, the galactic poles where the dust is thin. This created a massive bias in our understanding of the universe. We were building a puzzle with half the pieces missing, and we were pretending the missing pieces didn't matter. But as our technology improved, we started to realize that something was very, very wrong. We noticed that our galaxy, along with every other galaxy in our local neighborhood, was moving. And it wasn't just moving with the general expansion of the universe, it was being pulled. This is where the story takes a turn from technical difficulty to genuine cosmic mystery. Astronomers discovered that the Milky Way is flying through space at a staggering speed of over 2 million kilometers per hour. Now you might think, well, everything in space is moving, and you'd be right. But we weren't just drifting. We were accelerating toward a specific point in space. And wouldn't you know it, that point is located directly behind the thickest, darkest part of the zone of avoidance. This mysterious entity was dubbed the Great Attractor. It is a gravity anomaly so massive that it is dragging hundreds of thousands of galaxies toward it. It represents a mass equivalent to tens of thousands of Milky Ways, and yet for decades we couldn't see it. The very thing that is dictating the destiny of our entire region of the universe was hidden behind a veil of dust that scientists found too annoying to look through. Think about the irony of that for a moment. We spend billions of dollars searching for the origins of the Big Bang and the nature of dark energy, while a gargantuan structure is yanking our entire galactic neighborhood toward an unknown fate, and we just ignored it because the view was blurry. The Great Attractor isn't just a big pile of stars. It is a focal point of a massive supercluster of galaxies called Laniakea. When scientists finally started using X-ray and infrared telescopes to see through the dust, they began to realize the sheer scale of what we were missing. Infrared light has a longer wavelength than visible light, meaning it can slip between the dust particles like a person weaving through a crowded room. X-rays can punch right through. When we finally turned these eyes toward the zone of avoidance, the hidden universe exploded into view. We found thousands of galaxies that had never been cataloged. We found massive clusters that were previously invisible. But even with this new tech, the refusal to study this area persists in some circles of the scientific establishment. Why? Because the more we look, the less our current models of the universe seem to make sense. One of the biggest problems in modern cosmology is the bulk flow problem. According to the standard model of the universe, the distribution of matter should be relatively uniform on a large enough scale. This means that while things might tug on each other locally, there shouldn't be a massive universe-wide current pulling everything in one direction. But that is exactly what we are seeing. The zone of avoidance hides not just the Great Attractor, but something even further away and even more massive, sometimes referred to as the Shapley supercluster. Some controversial theories even suggest that there is something beyond the observable universe that is exerting a gravitational pull on our side. This suggests that our understanding of gravity or the distribution of matter is fundamentally flawed. For a scientist who has spent their entire life defending a specific model of the universe, the zone of avoidance is a nightmare. It produces data that is messy, hard to interpret, and often contradictory to established laws. Now, let's talk about the psychological aspect of this. In science, there is a concept called streetlight effect. It comes from an old joke about a person looking for their keys under a streetlight, not because they lost them there, but because that's where the light is. For a century, astronomers have been looking only where the cosmic light is. The zone of avoidance represents the darkness, the unknowns, and the too hard pile. But as any explorer will tell you, the things that are the hardest to find are usually the things that change everything. There is a quiet, simmering tension in the community. On one hand, you have the traditionalists, who believe we should focus on the data we can clearly see. On the other, you have a new generation of cosmic cartographers, who are convinced that the keys to understanding our ultimate fate are buried in the dust of the galactic plane. This isn't just about pretty pictures of galaxies. It is about whether or not we actually understand how the universe works. If you were to look through a radio telescope at the zone of avoidance today, you wouldn't see emptiness. You would see a chaotic, vibrant highway of energy. Radio waves are fantastic at penetrating the galactic disk. Projects like the Parkes Radio Telescope in Australia have spent years scanning this hidden half of the sky. They found something called the Norma Cluster, which is the heart of the Great Attractor. But even with these discoveries, the maps are still vastly incomplete. There are shadow zones where the density of gas is so high that even radio waves are scrambled. It is a true frontier. In an age where we feel like we have mapped every inch of our planet and much of our solar system, it is humbling and perhaps a bit frightening to realize that 40% of the extragalactic sky is still largely terra incognita. But why the word refuse? Well, it's about priority. When a new flagship telescope like the James Webb is launched, there is a fierce competition for observing time. If you propose a study to look into the heart of the zone of avoidance, your chances of getting approved are often lower than if you propose a study on a well-known, clean galaxy. The scientific establishment favors high-confidence projects. Looking into the zone is high risk. You might spend months collecting data only to find that the foreground noise from our own galaxy is too noisy to filter out. It's like trying to listen to a whispered conversation in a room where a heavy metal band is playing at full volume. Most scientists would rather go to a quiet room, but the people whispering in that noisy room? They are talking about the end of the world, or at least the end of the Milky Way. You see, the Great Attractor isn't just pulling us for fun. It is a gravitational drain. Eventually, millions or billions of years from now, the Milky Way and all the other galaxies in the Virgo supercluster will merge into this massive structure. We are part of a cosmic convergence. By ignoring the zone of avoidance, we are essentially ignoring the road we are currently traveling on. Imagine driving a car at high speed while refusing to look at the windshield because there are too many bugs splattered on it. You can look out the side windows all you want. You can see the beautiful scenery and the other cars. But if you don't know what is straight ahead, you are in trouble. This is why the study of the hidden sky is so vital. It's not just extra credit astronomy. It is the core of our cosmic geography. One of the most fascinating discoveries made recently in this forbidden zone are these things called Vela supercluster. This is a colossal mass of galaxies that was discovered only a few years ago. It's located even further away than the Great Attractor, but its gravitational influence is so massive that it actually accounts for a significant portion of the unexplained motion of our galaxy. The Vela supercluster went unnoticed for almost the entire history of human astronomy, despite being one of the largest structures in the known universe. It was hiding behind the dust. This discovery sent shockwaves through the community because it proved that we are still capable of missing ocean-sized astronomical features simply because they are in the wrong part of the sky. This brings up a deeper, more philosophical question. What else is hiding in there? If we can miss a supercluster of galaxies, what about smaller, perhaps more strange objects? Some theorists have suggested that the zone of avoidance could be hiding rogue black holes that were ejected from the center of our galaxy, or even dark galaxies made entirely of dark matter that don't emit light, but exert a heavy gravitational pull. There are even more fringe theories about clones of our own galaxy, or mirror structures. While these are mostly speculation, the fact remains that we don't know because we haven't looked enough. The avoidance isn't just a technical hurdle, it's a mental block. We like the universe to be neat. We like the Big Bang to explain everything perfectly, but the zone of avoidance keeps throwing wrenches into the gears of our neat little models. Let's look at it from the perspective of an alien civilization. If an alien astronomer was looking at the Milky Way from another galaxy, they would have a perfect view of what is on either side of our disk. They would see the Great Attractor and the Shapley supercluster clearly. They would probably find it hilarious that we are so blind to our own surroundings. We are like a person with a permanent blindfold over the middle of their vision. We have become experts at perceiving the periphery, but the center remains a mystery. And as we know from biology and psychology, what is in the center of your vision is usually what is most important for your survival. In cosmic terms, the zone of avoidance is our blind spot, and it is an enormous one. But things are slowly changing. The refusal is being chipped away by new tech. We are entering an era of multi-messenger astronomy. This means we aren't just looking at light, we are looking at gravitational waves and neutrinos. These things don't care about dust. A gravitational wave can pass through the entire thickness of the Milky Way as if it weren't even there. If a massive collision happens in the zone of avoidance, we can feel it through the ripples in space-time. We are finally starting to develop the inner ear of astronomy to complement our eyes. This is allowing us to map the hidden structures of the cosmos in ways that were unthinkable 20 years ago. We are finding that the zone of avoidance is actually one of the most crowded and active parts of the universe. However, the resistance remains. Why? Because the more we find, the more we have to rewrite. Textbook publishers hate the zone of avoidance. 10 years ago, the Milky Way was just drifting. 5 years ago, we were being pulled by the Great Attractor. Now, we are being pulled by the Great Attractor, the Shapley supercluster, and the Vela supercluster. It feels like every time we look into the forbidden region, the universe gets bigger, heavier, and more complicated. For a society that craves simple answers, this is an uncomfortable reality. It's much easier to focus on a single star or a single planet than it is to grapple with the fact that our entire galaxy is a leaf in a cosmic hurricane, being blown toward a destination we can't fully see. Science is often portrayed as a purely objective, logical pursuit, but it is practiced by humans, and humans are notoriously prone to ignoring things that are difficult or that challenge their worldview. The zone of avoidance is the ultimate challenge. It forces us to confront our limitations. It reminds us that no matter how many satellites we launch or how many equations we solve, nature still has ways of hiding its biggest secrets right under our noses. Literally. The dust that blocks our view is the same dust that makes up our own bodies and our own planet. We are made of the very stuff that prevents us from seeing the truth of the universe. There's something poetic and slightly cruel about that. So, the next time you look up at the Milky Way, don't just see a beautiful band of stars. See it as a massive, cosmic curtain. Recognize that behind that curtain there are monsters and giants. There are forces of gravity that could swallow our entire history without a second thought. And remember that there is a small, dedicated group of scientists who are tired of looking away. They are tired of the avoidance. They are the ones pointing their specialized sensors into the heart of the darkness, trying to find the pulse of the universe. They are the ones who realize that if we ever want to know where we came from and where we are going, we have to stop avoiding the most important part of the map. One of the biggest hurdles in this research is the noise of our own galaxy. You see, the Milky Way isn't just a static wall of dust. It's a living, breathing, noisy place. It's filled with pulsars that beep like cosmic lighthouses, masquerading as signals from deep space. It's filled with ionized gas that refracts radio waves, making distant galaxies appear to twinkle or dance. Filtering this out requires some of the most complex algorithms ever written. It's a bit like trying to find a specific grain of sand on a beach while a hurricane is blowing. But for the scientists who do this work, the payoff is worth it. Identifying a single new galaxy behind the galactic center is a victory. It's a small piece of the puzzle that helps us understand the bulk flow and the ultimate fate of our cosmic home. There's also the issue of dark flow. This is a controversial observation that suggests galaxies aren't just being pulled toward a mass, but are actually drifting toward a region outside the observable universe. This would imply that there is some structure so massive and so far away that its light hasn't even reached us yet, but its gravity has. Most of the evidence for this dark flow comes from observations that skirt the edges of the zone of avoidance. Because the data is so hard to verify, many mainstream scientists refuse to accept it. They call it a statistical fluke or an error in data processing. But the proponents of the theory insist that the only reason people don't believe it is because it's forbidden data. It is data that suggests our universe might just be a small bubble in a much larger, much more chaotic multiverse. Imagine if we finally cleared the dust. Imagine if, tomorrow, all the gas and dust in the Milky Way suddenly vanished. The night sky would be transformed. Instead of a dark band, we would see a glowing wall of light. We would see the Great Attractor as a massive, shimmering concentration of galaxies. The sky would be crowded. We would feel much less alone, but perhaps much more precarious. The dust gives us a sense of isolation, a sense that we are in a quiet corner of the cosmos. The reality is that we are in the middle of a cosmic metropolitan area, and the zone of avoidance is just the foggy window through which we are trying to look at the city lights. The refusal to study this area isn't just about the telescopes, it's about the funding. Agencies like NASA and the ESA have to justify every dollar to taxpayers and politicians. It's much easier to sell a mission to Mars or a mission to search for life on an icy moon. These are relatable goals. Mapping the hidden superclusters of the zone of avoidance? That sounds abstract. It sounds like something for the next century. But the truth is, the physics of the zone of avoidance might be the very thing that explains why those icy moons exist in the first place, or how our galaxy was formed. Everything is connected. By ignoring the connective tissue of the universe, we are failing to see the whole picture. Let's talk about the Great Wall. No, not the one in China, but the Boss Great Wall. This is another gargantuan structure of galaxies, one of the largest ever discovered. Like the others, it was found at the very limits of our ability to see through the galactic clutter. Every time we find one of these walls or filaments, we realize that the universe has a structure, a web-like appearance. The zone of avoidance is often where these filaments intersect. It's the junction box of the universe. If you were trying to understand how a house is wired, you wouldn't just look at the light bulbs. You would look at the junction boxes behind the walls. Scientists are finally starting to realize that they have been looking at the light bulbs for 100 years while refusing to look behind the wall of the Milky Way. But why the fear? I mentioned that some scientists are quietly terrified. This isn't horror movie fear, it's intellectual dread. It's the fear that our basic assumptions about the universe are wrong. We assume the universe is isotropic, meaning it looks the same in every direction. If the zone of avoidance hides things that break this symmetry, then the Big Bang Theory needs a massive overhaul. This could mean that the universe has a center or a preferred direction. It could mean that the laws of physics aren't the same everywhere. For a scientist, this is like finding out that 1 + 1 doesn't always equal 2. It's the ultimate crisis of faith. And the zone of avoidance is where all the evidence for this crisis is hidden. We are also finding voids in this region. Massive, empty spaces millions of light years across where there is absolutely nothing. These voids are just as important as the superclusters. They push galaxies away just as surely as clusters pull them. The interaction between these pushes and pulls is what creates the bulk flow. By ignoring the zone of avoidance, we are missing half of the engine that drives the motion of the universe. We are looking at the car moving but refusing to open the hood because we don't want to get our hands greasy. But the grease is where the answers are. As we move forward into the middle of the 21st century, the avoidance is becoming impossible to maintain. New terrestrial telescopes like the Vera the 100th Rubin Observatory in Chile will soon begin the most comprehensive survey of the sky ever attempted. It will take images of the entire visible sky every few nights. It will generate so much data that we won't be able to avoid anything anymore. The zone will be flooded with data. We are about to enter the golden age of the zone of avoidance. We are finally going to see what is behind that door in the museum. And whether we find a cosmic monster, a new law of physics, or just more beautiful galaxies, it will change our place in the universe forever. So why do they refuse? Because it's hard. Because it's messy. Because it challenges what we think we know. But hard and messy are where the greatest discoveries live. The zone of avoidance isn't just a physical place. It's a reminder of the limits of human knowledge. It's a challenge to the next generation of astronomers. It's an invitation to stop looking at the streetlight and start walking into the dark. Because in the dark, you might just find something much better than your keys. You might find the secret to everything. The avoidance is essentially a human construct. The universe doesn't care about our dust. It doesn't care that we can't see through it easily. The great attractor will keep pulling, the superclusters will keep glowing, and the voids will keep pushing, whether we choose to document them or not. Our refusal to study them is only a delay of the inevitable. One day we will have a complete map of the cosmos. We will see the filaments of the cosmic web in their entirety, stretching through the galactic plane like the veins of a titan. We will look back on the era of the zone of avoidance as a time of cosmic infancy, the time when we were still afraid of the dark. In the end, maybe the reason we avoid it is simpler. Maybe deep down we like the mystery. We like having a part of the sky that is off limits. It leaves room for our imagination. It leaves room for the unknown. In a world where everything is tracked, mapped, and analyzed, the zone of avoidance is the last great wilderness. It is the deep forest of the stars where anything could be true. And while the scientist in us wants to shine a light on it, the dreamer in us might be perfectly happy letting it remain a secret for just a little while longer. But the light is coming. The telescopes are turning. The dust is being pierced, and when the final curtain falls, we will finally see the universe for what it truly is, not just what we wanted it to be. The study of space is often about looking as far away as possible. We look for the first light of the Big Bang, billions of light years away. But the zone of avoidance reminds us that some of the most profound mysteries are much closer to home. It's the backyard of the Milky Way. It's the basement of our galactic neighborhood. We've spent so much time looking at the distant horizon that we've forgotten to check what's under the floorboards. But the floorboards are vibrating. The great attractor is humming, and the universe is waiting for us to stop being afraid and finally take a look. The journey into the zone of avoidance is not just a journey of miles or light years. It's a journey of perspective. It's an admission that we don't have all the answers. It's a confession that our perfect models are incomplete. But that admission is the spark of all great science. The refusal to study it is a sign of arrogance, but the curiosity to explore it is a sign of our potential. As we pierce the veil, we are not just finding new galaxies, we are finding a new version of ourselves, a version that is brave enough to face the darkness and see the light hidden within it. The zone of avoidance is waiting. It's time we stopped avoiding it and started embracing the beautiful, chaotic, hidden truth of our cosmic home.